everyone, I'm Paul. I'm going to explain to you the basics of the pathophysiology of Parkinsonism, which is the article title from the 2008 article from the National Institute of Health, going over the basics of the pathophysiology of Parkinsonism. So, what it is a collection of multiple neurodegenerative disorders affecting multiple regions within the brain that result in both motor impairment and, most likely, eventually physical disability. So the motor impairment is largely due to the degeneration of dopamine-delivering neurons in the midbrain. So I'm going to show you a diagram in a second that compares normal versus Parkinson's and how the changes in the motor loop of the basal ganglia take place in a person who has a normal brain connectivity and a person who has Parkinson's brain connectivity. So the black arrows, they indicate inhibited connections, the gray arrows indicate excited connections, and the thickness for both indicates the presumed level of activity. So if we see a thicker arrow, we see heightened activity. If we see a thinner arrow, we see lesser activity. So, person with a normal brain. Premotor cortex, signaling pathways, central motor cortex. We see that the excitatory signals and the inhibitory signals are relatively the same, and right here in the substantia nigra, which is in the midbrain, in the basal ganglia, essentially what we see is that dopamine output is the same either way. So this is a regular amount of dopamine coming out. In a person who has Parkinson's disease, we see the premotor cortex, the excitatory signals are actually already decreased, coming from the premotor cortex. And from the substantia nigra, we see that there's impaired level of dopamine output. So in the indirect pathway, we see that the signal is more excited than it had previously been, so it is stimulated. The indirect pathway is stimulated by the impairment of dopamine output, and the direct pathway is lessened. Going into the striatum right here, so we see that this is your central motor cortex, your striatum. It's your central motor cortex leading to your brainstem and spinal cord. These excitatory signals are an increased movement. So basically what this all means, the process of it, the normal pathways have consistent size and presence. So the dopamine isn't as present, it's impaired in person with Parkinson's disease. Parkinson's disease, we see that the direct premotor pathway signals to the movement activators, they are diminished. In the indirect pathway, they are heightened. The end result is that dopamine release stimulates the direct pathway, but it inhibits the indirect pathway, which is the opposite of Parkinson's, which is essentially what we want, right? So this increases the activation of the cerebral motor cortex, leading to movement, and that is in the striatum. So an example of all of this is essentially what happens after you have activation of the motor cortex. We get firing rate. So these are electrophysiological data from monkeys. So firing rate, think of something like an EMG, an electromyograph. So this is activation of these different signaling pathways. So we can see in a normal monkey, we see that the signals are more or less consistent, except for this one signaling protein, but that's to be expected. They're very consistent, very normal. In a person with Parkinson's, we see that right here they're actually heightened. In these two proteins right here, they're actually heightened. So the amount of signaling is increased, which is what we saw in the thickness of the arrows on that diagram. So they're increased, and they also come in bursts. So if we think of Parkinson's, you usually see tremors, and so those are actually all of those, that's the increased excitation, but in burst mode. I'm sorry for the color on this graph. It's actually white in the paper, and I couldn't get it to show up white on here, don't know why. So in a normal brain, this is normal, this is Parkinson's, in a normal brain we see that it's still more consistent along the way, except for that one signaling protein that I told you about, but like I said, that's to be expected. And in persons with Parkinson's, we can see that there's more bursts. So excitation, break, and so forth.